Loading familial phantoms next on 6 Ed World.
I am working on a project where I'm using a Game Boy Pocket shell, or at least the top, and a DS light system. And I want the DS light to be in the footprint of the Game Boy Pocket. This takes a bit of work to do. I had to make my own lower shell. And I 3D printed mine. I want to get this into the finest quality that I can, and that requires a little bit of filler primer, body filler, lots of sanding to get it smooth and looking kind of like this ABS shell. So I get lots of questions on how do I go about making brackets and making fills and stuff like that, and I thought this might be a good chance to go over my process. For my process, this is basically all I use. I'm going to be using not a multimeter, what is this? A caliper. And I have a digital one. I bought this off of Amazon. They're pretty cheap. I think this one was maybe $15 on the cheap side. The next tool, the common and humble Dillon's ballpoint pen. I'm using this shell for illustration purposes in just a standard notepad. What I need to do on my shell that I have over there, I need to fill in what was the contrast port. I've already 3D printed something to fill that in, but I had this opening, so I needed to fill that in some way. And I could have used Bondo, for example, but Bondo it's extremely smelly, it leaves a lot of fumes, and if you're working in a closed space like I am, I'm in an apartment, the fumes can give you a headache and you don't really get any fresh air or escape from it. So in order to cut down on using Bondo and the fumes, I'm just going to fill in most of this with a 3D print. So how I go about doing that, get the calipers here. Going to be hard to read because I think the battery is about dead. You can see that, right? Okay. First step is just to take your measurements. I'm going to measure width. You can see that's about 16 mil. Start off by doing a enlarged representation of what I'm doing. The width was 16 mil. Yeah. Need to measure. Come on now. Need to measure what I call the height. A rough estimate, that one. It's about 3 mil. And then we need to measure thickness here. Go until I hit the back, kind of wiggle it around so I can get a rough idea. And it looks like we're at 1.3. Let's hop into the CAD and let me show you how I go about designing my part. Alright, we're in Fusion 360 now, and this is my CAD software of choice. It is free to use as a hobbyist, so I can't recommend it enough. And you're going to see that the sizes that I'm putting in for the part aren't exactly going to match what I noted earlier. I recorded this in an earlier session so I can get these parts developed and get my shell worked on. So I'm going to show you what I recorded earlier. I'm just quickly roughing out these parts. It's pretty simple, just using the rectangle tool, extruding them to the length that I need, and I'm color coding them so I can organize a little bit better. Once you get your parts developed in CAD, you can save them out as an STL, drop them into your slicer of choice, and I have my own 3D printer, so I'm able to print these off from home. I've got my part printed, and now I'm going to super glue it on. I like to use a little bit of Captain tape to hold it in place. The Captain tape doesn't stick to super glue very easily, so it's a really good hold while this part dries on. After giving this about 15 minutes to dry, I can come back and add a light layer of spot putty, any kind of filler that you need to continue your body work. And this is roughly how I do my 3D part design, the 3D printing process of what I do. And these parts, they're not always this simple. In fact, they're usually way more complicated. But I hope at least I got my design process out there for others to check out and maybe learn from.